for today's notes, we'll be talking about functions. So a function is a relation where every x has exactly one y value. So that means that I cannot have 3 as my x value going to 2, 1, and 4. In other words, to simply put it, the x values cannot repeat. So here's a little analogy for you. So here it says consider the domain, and our domain, that's another word for x. You can also think of the word input, independent, and it is to be a set of people on a bus. Think of each bus stop along the way as the range, which is our y. The function of the bus is to deliver people to their respective destinations. Okay, so it is possible for 2 or more people to get off at one bus stop. However, it is not possible for that same person to get off at 2 different bus stops. So if you think of, for instance, if I have Patrick on my bus, he cannot get off at the first bus stop, the second bus stop, and the third bus stop. However, I can have Patrick, Kenzie, and Kayla, I can all have them getting off at one bus stop, but they can't get off at multiple. So a person X is associated with only one bus stop. So after that analogy, let's go ahead and look at our next page. Okay, so looking at ordered pairs and tables, you are going to have to look at these to determine if they are a function. So again, if a set of data is a function, each X value is paired with a unique Y value. So in other words, you have an X value being paired with only one Y value. You cannot have multiple X's or an X to multiple Y's. In other words, just to simply put it, the X's do not repeat. So looking at example 1 here, we have these ordered pairs. I'm going to go ahead and underline these. So here I have 3, I have 4, I have -2, and I have 0. So looking at my X values here, none of my X values repeat. I do see that my Y values repeat, but that is okay. My Y values can repeat, but what cannot repeat are my X values. So that means that since my X values do not repeat, this is a function. Okay, but looking at example 2, I'm just solely looking at my X values. Here I have a 3, and a -2. And because these 3's repeat right here, this means that this is not a function. Now looking at example 3, now we're looking at tables. So for our tables here, we have -2, 0, 3, and 4. Looking at this table, I don't have any X values that repeat. However, I do have Y values that repeat, but that is okay. I can have Y values repeating. I just can't have X values that repeat. So this means that this is a function. But looking at my X value, looking at example 4, now looking at my X values here, I have -2, 0, 3, and 3. Now, because I have these 3's repeating on this table, that means that this is not a function. Okay, so that was looking at ordered pairs and tables. We're going to go ahead and look at graphs now. So a graph is if a set of data is a function, we can determine if it is a function by what we call the vertical line test. So here, if a set of data is a function, a vertical line will cross the graph of the data in only one point. In other words, when I do my vertical line test, it shouldn't pass through 2 points. I'm going to go ahead and zoom in so we can take a closer look at example 5. Okay, so looking at example 5 here, I'm going to perform the vertical line test. Now, if it's a vertical line, remember it goes up and down. So here, on my vertical line, I'm going to draw it through every point. Here I see that it does not cross through more than one point. Going here, for my next point, I draw my vertical line and I see that it does not cross through any of these points. I'm going to keep going. It does not cross through more than one point. Now what's going to trip some people up is they're going to draw their line horizontally. Now that is wrong. It is not called the horizontal line test, it is the vertical line test. So if you were to have drawn this horizontally, you would have thought that this was not a function. But if I keep going, I see that if I keep doing my vertical line test, it never crosses through more than one point. So that means that example 5 is a function. Now let's go ahead and look at example 6. Okay, so now we're looking at example 6, and again we want to do our vertical line test. So again, I'm going to draw my lines up and down, hitting all the points on my graph. So here, if I draw my line, I see that my graph, that line does not go through more than 1 point. If I keep going, this vertical line only goes through 1 point, but if I look here, whenever I do the vertical line test over these 2 points, they go through the same line, which means this failed our vertical line test, which means that this cannot be a function. So this is not a function. Okay, so that was graphs. Let's go ahead and look at our next category, which we call mappings. Okay, next we have mapping. So here it says if a set of data is a function, each element of the domain, which is our x, is paired with only one element of the range, which is our y. So here, looking at example 7, we have our domain on one side and our range on the other. So here first, our first number in our domain is 3, and it is being paired with the number 2. So that's telling me that my x value is 3 and my y value is 2. I believe it kind of helps if you kind of write out your ordered pairs just to get a better look at it. So next it's telling me that the number 4 is being paired with 2 from our range. So that's 4, 2. Next I have negative 2 being paired with 0. I'm sorry, negative 2 being paired with 3. And then I have 0 being paired with 0. So now if I look at my x values, which are these values right here, they're the first letter, the first number, I see that I do not have any x values repeating. So what that tells me is that this is a function. However, looking at example 8, I'm going to go ahead and zoom in. So again, I'm pairing the numbers in my domain to my range. So here I have these 2 lines coming from my domain, my x value. So what this is telling me, I have 3 being paired with 2, and I have 3 being paired with 3. I also have negative 2 being paired with 0, and I have 0 being paired with negative 1. Now, here I see that I have my x values. Here I have my x values, and here I see that I have these 3s, these x values, they're repeating. So what that means is that it is not a function. So a quick trick on how you can tell if a mapping is a function or not, you can see if you have 2 lines coming from your domain. So here I had 2 lines coming out of one element from my domain. However, if you looked back at example 7, you have 2 lines coming from a range. Now that is okay. You just cannot have 2 lines coming from your x value. So this, again, is not a function. Okay, next let's look at some practice problems. So it says, are the following examples of a function? So looking at number 1 here, I'm going to go ahead and underline all of my x values. So I have negative 4, I have a positive 5, 0, 1, 8, and negative 2. Now looking at my x values, I don't have any x values that repeat. So that being said, this tells me that this is a function. Okay, next, we're going to go on to number 2. So here we have a table. So here at my table, looking at my x values, I have a positive 2, a positive 4, 6, 8, and 10. Again, I don't see any x values that repeat, so that means that this is a function. Now, looking at number 3, we have a mapping. So here I have 2 lines coming from each x value. So this is 4, negative 3, 4, negative 1. And if I keep going, I'm going to have 4, 5, and 6, and they're all going to be repeating. So what that means is that this is not a function. Okay, let's go ahead and look at our next page for some more practice problems. So looking at number 4 here, so we have a graph, and if we have graphs, we have to perform the vertical line test. So I'm going to go ahead and perform the vertical line test. and I'm just going to draw a whole bunch of lines through this graph. Here I see if I keep doing this, it passes the vertical line test every time. So what that means is that this is a function. It passed the vertical line test. Now looking at number 5, if you were to draw your line horizontally, you would believe that this was not a function because you would see that it crosses through more than once. However, if you do it the correct way, if you do the vertical line test, going through here, I see that it passes the vertical line test. So this is a function. Okay, let's go ahead and look at the bottom here. Okay, for number 6, it says, which domains would make the list of ordered pairs a function? So here they only gave me one x value, and that was the number 3. So in my answer choices, I should not have the number 3 in them. That being said, I can eliminate A and I can eliminate C. Now looking at the rest of them. Here for B, I only have 2 numbers, so that means that one of them is going to have to repeat. So that is incorrect. Next, I have 5, 1, and 4. So if I were to put 5, 1, and 4, looking at my x values, I do not see any x values that repeat. So that could be one of the list of ordered pairs that would make this a function. Now, if I were to look at E, just based on the answer choice alone, I see that I have a 2 and a 2. And if I were to write that in, I would have x values that repeat. So that's wrong. And then I have F. So here I have 2, -5, and -3. Looking at my x values, I don't have any x's that repeat. Now here you do have a 3 and a -3, and for some of you, you might think that that is showing that your x value is repeating, but it's a positive and a negative. So they're not the same number, so that is good, and that means that D and F are ordered pairs that would make these this set of ordered pairs a function. So D and F. That was your notes for functions. Go ahead and complete your assignments. And if you have any further questions, please reach out to us.